So we're stepping up our game a little bit with these. So these are a little bit tougher than the Delta Math practice, but they test the same skills. So these are going to be representative of the hardest problems you'll see on the quiz in the next lesson. So they're both biology questions, which if you like biology, you should be interested in these. If you don't take biology and you are interested in these, you should probably take biology next year. So this one is about penicillin, which is an antibiotic that kills bacteria. So you can imagine that we're introducing penicillin to a dish of bacteria, and we know that the changes in population are going to follow a pattern of exponential growth or decay. So what we want to do is find a model that models the population of bacteria in the dish on day X. So if P of X, if we know that this is exponential, we know P of X is going to look like this. A times B to the X. And then we need to use our skills to figure out what B is and what A is. Okay. Well, A is actually given to us if we look closely. So day 0 gives us A, so P of X is going to be 2,157 times something to the X power. Okay, now we need to figure out the B value. So remember, the B value, there's some number that I multiply each of my Y values by to get the next Y value. So in this case, the way I might figure that out is I might take something like 1802. So population on day 1 divided by 2,157. And you get, I believe, something like 0.83. We'll say 0.835, and I rounded there. So the next digit was a 4, so I rounded down. Okay, so that's my B value. So 0.835 times my first population on day 0 will give me 1,802, and then multiplying by it again will give me 1,505, and so on. So 0.835. And that's my function. Okay? So I could, if I wanted to know what the population would be on day 30, I could put 30 in for X and punch this into my calculator and figure out how many bacteria would be left in 30 days. And then the question is, why does it make sense based on the data that my B value is less than 1? So why does it make sense that B is less than 1? Well, B, let's make sure our B value is less than 1 first of all. So 0.835 is definitely less than 1, right? And let's think about what that means. So when we multiply by a decimal, by a number that's less than 1, what we get is a smaller and smaller result each time, right? And that's consistent with our data. So one answer might be that the data shows, we could call this exponential decay, which means our population is getting smaller. So we could say that. Or we could go back to the text of the problem even, and we could say, we know that penicillin is an antibiotic that's killing these things. So again, our population should be getting smaller. So a couple of different answers there, meaning basically the same thing. So if the drug is killing bacteria, that means we should have exponential decay. So you could answer based on the text or the table here, and I think that would be okay. All right, now our next problem. So before we move on, now is a great time to pause, make sure you have all this. This is a great example to capture in your notebook. And if you have any questions, go back and rewatch first before moving on. Okay. Then my next question here. So biologists can estimate the age of an African elephant based on the length of an elephant's footprint using the function L of t equals blah, blah, blah. And L has an E in it, and the key takeaway from our last lesson is that E is a number, not a variable, right? And then L of t, I'm going to annotate this is important. L of t represents the length of the footprint, and T represents the age of the elephant. So this kind of makes sense, right? So the size of an elephant's foot, just like the size of a human's foot, is generally related to their age. As the elephant gets older, the foot gets bigger, and so on. And then this tells me to find L of 0. So this is not new for you guys. L of 0 means, plug it in to my function. Remember, E stays the same. E is equal to about 2.71. And then 0 goes up here. And really, right, we don't need our calculator to even evaluate this, because what we probably remember is anything to the 0 power is just 1. So 25.7 e to the 0, because 0 times 0.9 is 0. And e to the 0 is 1, so really I'm just doing 45 minus 25.7. And here we might reach for a calculator, that's okay. But I will get, what will I get? 19.3. Okay, so that's the easy part, just plugging it in. And remember, there's an E button on your calculator if you need it. So now I need to figure out, what does this mean in context of the problem? Well, remember, this is L of 0. So this is my L value at t equals 0. So I'll write t equals 0. And while t equals 0, t represents the age of the elephant, so 0 years. And then 19.3, L of t is the length of the footprint in centimeters. So 19.3 centimeters. So really the only thing we need to think about is this 0 years part. And really what we're talking about is year-old elephant is a baby elephant. So a great answer here would be baby elephant makes a 19.3 centimeter footprint. And that's it. So if you had an easy time with these, you'll have an easy time with the quiz. As always, during the quiz, you're welcome to come back and rewatch this video if needed.